In this podcast, we'll find the maximum of a quadratic function in an application problem. We're told at $10 per ticket, the cover band can fill all 8,000 seats in the Rose Lehman Arts Center. The center manager knows for each $1 increase in ticket price, 400 tickets will go unsold. What price would maximize the revenue? So first up for this is to find, well, what's a relationship between the price and the number of seats? We want everything to be in terms of the price, since we're looking for the ticket price that maximizes revenue. So we want to find, well, how do we get the number of seats as a function of the price? So one way is to use a table to help us see this. For different prices, we can see, well, how many seats do we have? We know at $10 per ticket, we have all 8,000 seats sold. For each $1 increase in ticket price, if we go up to $11, we know we'll have 400 less, so it's 7,600. For $12 tickets, it'll be 400 less than that, 7,200, and so on. Use the table to help you see this, but this is really giving us a linear function. We can think of the number of tickets as a function of price. It's a linear function. Well, to find a linear function, we need to know first the slope, the change in the output. The output here is n. And if we use these 2 points, 8,000 minus 7,600 over the change in the input, 10 goes with the 8,000 and 11 goes with the 7,600. Well, again, we have 400 over 1, negative 1. So that's saying our slope should be negative 400. Well, that's really what this line is telling us. For each increase in ticket price of $1, 400 tickets will go less unsold, meaning we'll sell 400 less seats. Well, we have the slope. To finish the linear function, we just need to know a point on it. Well, when the price is 10, the number of tickets is 8,000. So setting it up in my point slope form, I know the number of tickets minus the number actually sold, 8,000. That should be equal to my slope times the price minus 10. Bringing everything to the other side, I can see the number of tickets should be negative 400 times, well, each price increase over 10 plus 8,000 tickets. It sometimes is a little bit more helpful to simplify this. So if we distribute this out, negative 400 p plus 4,000 plus 8,000, well, to get the number of tickets in terms of the price, it's negative 400p plus 12,000. A good way to check that this is the correct function, we'll plug in some of the other ticket prices. When we plug in 12 into this function, so negative 400 times $12 tickets, is that plus 12,000 going to give us what we're looking for, 7,200 seats? Looks pretty good. That's a good way to check to make sure you have the correct function. Well, now we want to come up with the revenue. Find the revenue function as a function of the price. Well, revenue depends on two things. Depends on the price and the quantity, the number of tickets that are sold. Well, we said P was the price and the number of tickets was N. Rewriting this all in terms of price, well, P times negative 400, P plus 12,000, that should give us the revenue function, which tells us at any particular price, to find the total revenue, how much money is taken in, should be negative 400 p squared plus 12,000 p. So to maximize this, we want to see it as a quadratic function. There's a couple ways to do that. One way is we can rewrite this in vertex form. That a times the quantity x minus h squared plus k. So to rewrite this, we're going to complete the square. So one thing I can do is factor out this negative 400 first, make it a little bit easier. So it's negative 400 times, well, on the inside I should get p squared, and dividing out the negative 400 into the 12,000, I should get a minus 30p. And the idea is we want to complete the square on that quantity. So rewriting it, to make this into a perfect square, we want to add, well, half that middle term squared. Half of the middle term, well, the middle coefficient is negative 30, half of it is negative 15, so half of it squared, negative 15 times negative 15, should give us 225. So I want to add and subtract 225 on the inside of those brackets to make it into a perfect square. Well, this part here, that's going to be a perfect square. So rewriting it, negative 400. My p squared minus 30p plus 225 factors into p minus 15 quantity squared. And I have a minus 225 left over from that. So distributing it so I can see it in a more helpful form, in this vertex form, the revenue function should be negative 400 times, well, p minus 15 squared, and the constant, I have negative 400 times that negative 225. So altogether, 90,000. So if we want to know the maximum revenue, the nice thing about this vertex form is, well, that constant part, that's the maximum revenue. But we were looking for, what is this optimal ticket price? Well, the ticket price is really the input value, or the X value. So the best ticket price is $15 per ticket. When I sell tickets for $15 each, it's saying the concert hall is going to make a revenue of $90,000 on this concert.